Today, I'm going to talk about how the light conduction through the shoot affects the plant's geotropism. And the background story is that the light goes to the stem. There are numerical researches that back up that the light goes through the stem and into the root through the vascular tissues, which work like optical fibers. And my research question was that how it affects the geotropism of the root. And in order to change the light conduction through the inner tissues, I prepared a transparent and a non-transparent black gelatin, and I inserted between the plant, which was caught in transsectionally. And my hypothesis is that the geotropism will decrease if the light is not conducted. And I saw a similar research with a different species that had the similar result. And I wanted to see if it applies to this species, because this topic is quite recent, and I want to know how huge role the function plays in a plant. And my method is that I cut the plant in half and inserted the gelatin layer inside, and then I covered it with the tape, and then I put it on there so it can grow, whereas these things can it's a fabric that absorbs water, and then I cover it with the white tissue, paper towels, and it was left from above. The independent variable is the conduction of light, and as I said, I control it by the different gelatins. And my dependent variable is the geotropic curvature of the root, which was measured by the lateral root growth. Lateral root growth is the root that grows in not the main root, but then that grows from the root, which is comprised of the one single cell. And then to compare the change by time, I had to take a photo. I took two photos and compared them. And in order to be a fair comparison, I had to have the same angle when I take the photo. So therefore, I use this tube, it's a red transparent tube in the shape of a cylinder. So when the circle in one side and circle in one side overlap each other, I know that the camera is taking photo from vertically, from 180 degrees from the plant, and 90 degrees from the cylinder. And the control variables were selected by three aspects. Either they affect the plant growth or tropism, or the photochrome B. Photochrome B is that detects light, but it also exists in the root, in the inner tissues. And in order to control the plant growth, the light intensity and the amount of water was controlled. Light intensity was controlled by using a same light bulb which has the same watt with the same distance. And water was controlled using an atomizer by 3 times. And the tropism is a very sensitive thing. We can be changed by other factors, such as the light conduction directed to the root and the difference in the chemical component. So therefore, I covered the root with an aluminum foil, so it reflects any light that goes to the root. And the confounding variable is the genetic variability, which was reduced by the amount of trials. Initially, I planned 50 trials, and it became 31. But however, according to math, the central limit theorem, a t distribution approaches normal distribution at 31, and the t-test has its validity in 31. And I think because the genetic variety is in the case is talking about the variance of the statistics, so I don't think it had affected that much. This is a method that I talked. Oh, so when I put the cardboard, I put it like vertically from the ground and put the light bulb like horizontally. And then I turn it like 90 degrees right, so I can change the direction of the gravity and measure the angle of the lateral root growth. Unfortunately, even though I planned 5 plants and 10 trials, which meant to be 50, I only had 31 trials because the main reason is that when I cut the plant, although the gelatin can be a medium that transport like water-soluble things, because it's cut, the hormones were concentrated in the part that is cut, and then the bottom part that is connected to the root grew in a different direction because the tape did not like fold it tight. So I had to give up 20 trials. And these are the results. When I proceed in the graph, whereas the error bar indicates the standard error, there was a significant decrease using a black gelatin than the transparent gelatin with account of the error bars. And thanks to central limit theorem, I could use the t-test. From the t-test, it means that the black gelatin reduces the plant sensitivity to the gravity for the root growth is significantly smaller than that of transparent gelatin. And if I compare it with the preliminary literature, although it was different species and the different method, it showed the same result. And the preliminary, because to prevent the effect by the light conduction, you can either prevent the light conduction or the plant's perception. And this research created a mutation in the plant and eliminated the photochrome B in the root. And we used the different species and still gave us same result. And because although like my research showed a significant difference, because my experiment was not so efficient, I thought of different ways to conduct the experiment. One is to use a glue rather than a tape, because tape, although I tried a lot, it forms some kind of gap between the plant and the tape, which makes the bottom part grow in a different direction. So if I use the liquid glue and coat it around, it might not happen. And also I could use alter the genetic expression of the photochrome B. Although it's not mutated, I can just change the genetic expression. And the problem about the cardboard turning 90 degrees, because the thing about the bottom part growing in a different direction, I thought it's because of the tropism, like geotropism, because when the plant is moved from horizontal, it tends to go to vertically. And then to prevent this, instead of rotating the cardboard by 90 degrees, if I grew the plant in a flat area, so the root grows vertically from the shoot. And then if I initially grow it in a solid area, so that the shoot will go vertically, whereas the root goes horizontally. If I change it to a semi-liquid area where the root can grow this way, like vertically, then I could measure the effect of geotropism, whereas not touching the shoot direction. And this is my bibliography.